Hello, our team name is The Believers. This is our design review, and the members of our team are Josh, Lily, and Kruin. For our design requirements, we have a size requirement of it fits inside a box of that dimensions as seen. We have to put the ghost into a few centerpiece quadrants, and we have to get the balls inside of a van which is taller than the robot, and the robot has to move off the platform and stop entirely while not interfering with the platform. An overview of our design. So we first show the propeller system, which puts 3 balls down the ramp into the quadrants. A launch system was chosen for the Friends. I used an actuator, hits it out. The bump switch tells when the turntable propeller system should turn. The 2 levels, we have one for storing all the mechatronic stuff, and the second level for doing everything with the ping pong balls. We have a hole on the side of our robot for the cords. We have large gears so that they mesh easily, and a bumper so that it reaches the distance every time.
We learned a lot between our first and final design. What changed was the dimension tolerance on the outside. We made our gears longer in width so we didn't have any issues with it slipping. We added an actuator to launch balls into the top. Something that stayed the same was the ramp and propeller system, and then we added a bump switch and a bumper onto that just to make it more consistent every time. MDF wheels worked well, everything else was good. So our robot is basically split into a consistency element and then a risk element. We focused a lot on accomplishing full egress and depositing all of the ghosts with our propeller system. Basically, we wanted to get 88 points, no problem, every time. After this, we decided to use a launch system for the top. There's a lot of pros to this, less time spent developing and way more time to test. Though it might seem as not as consistent because we had more time to test, it allowed for more consistency, lower risk for damage, and less material was used. System 1 is our consistent system, the propeller system. As you can see from this section view, it is angled so that way the ball just immediately rolls down whenever it turns. Basically it works, bumper hits first, then the bump switch is activated, and then it moves in pulses of speed so that way the balls will roll down consistently every time.
The next system for a robot is the actuator launch system, which is created with press fits and 3D printed design for reliability and ease of manufacturing. It also features a ramp that can hold 4 ping pong balls, which are launched in successive quick motions. And there's also a backup plan for this, featuring a tray at the front of the robot that would roll balls while they're contacting the track in order to score points that way. After finishing the robot, the overall design features a good aesthetic, and the systems that were previously aforementioned. One interesting note is the hole in the left image that is the wires are going through, which is nice because this eliminates any tugging in our design. Also, the design features a lot of press fits for easy access, as well as the big hole at the front as well for accessibility. Here's our bill of materials for the robot. The total cost was $42.84, which is much under the budget. Here's an overall CAD model of the robot featuring all of the systems previously discussed. This is another view of the CAD model, and we used CAD in order to do rapid prototyping, saving both time and resources. And then here is an overall CAD drawing showing some overall dimensions for the robot.